Uranus and Neptune are somewhat of a mystery because in a way they shouldn't exist, or at least they shouldn't exist where they are. The James Webb Space Telescope has beamed back a breathtaking image revealing the icy giant in stunning detail, the best we've seen in 30 years. But hold on, this isn't just a pretty picture. Out where Uranus and Neptune are, tons of ice, tons of frozen gases as we might think of them, methane, ammonia, water. That's what makes up their composition predominantly. This new view can tell us more about what's beneath Neptune's stunning blue surface, as one of the least explored planets in our solar system. As you move further out in the solar system, the timescale for two bodies to find each other and collide slows down because the periods around the sun are much longer. It just takes a very, very long time. Neptune is a world full of mysteries waiting to be figured out. Prepare to be surprised. We're about to dive into what the Webb telescope has revealed and why Neptune might be more fascinating than ever imagined. James Webb's image of Neptune. For over 3 decades, our best glimpse of Neptune remained a single image captured by the Voyager 2 spacecraft in 1989. Launched in 1977, Voyager 2's mission wasn't solely focused on Neptune. It was designed to explore the entire solar system and eventually depart into interstellar space. While the Hubble Space Telescope also offered some views of the distant ice giant, the detail wasn't enough to satisfy the scientific community's thirst for knowledge. All of that changed with the highly anticipated launch of the James Webb Telescope, JWST. September 2022 marked a turning point in Neptune's story. The JWST not only delivered the clearest picture of its rings in over 30 years, but also revealed the planet itself in a completely new light. This revolutionary view was captured by the NIRCam instrument, which operates in the near-infrared range invisible to human eyes. In these wavelengths, Neptune appears remarkably dark, a stark contrast to its familiar blue hue. This darkness is likely due to methane gas, which strongly absorbs red and infrared light. Compared to the gas giants Jupiter and Saturn, Neptune is much richer in elements heavier than hydrogen and helium. However, the image isn't devoid of brightness. The contrasting bright stripes and spots are actually high-altitude clouds composed of methane ice, reflecting sunlight and appearing almost white in the NIRCam image. This technique, alongside the superior resolution of JWST, allowed for the first clear view of Neptune's fine ring system, which scientists suspect are made of ice crystals. While these rings were known from Voyager 2, previous technology struggled to capture their details. Another interesting feature revealed by the JWST image is a thin, bright line encircling Neptune's equator. This line is a telltale sign of powerful atmospheric circulations, essentially violent winds and storms raging on the planet's surface. The image also provides a clear view of a previously known vortex at the South Pole, and, for the first time, depicts a continuous band of clouds enveloping Neptune at higher latitudes. These advancements in observation technology allow scientists on Earth to utilize light filtering methods and remotely determine the composition of gases and other structures on Neptune. Studying the rings alone, first observed by Voyager 2, promises exciting new insights into the composition of this distant ice giant. For astronomers, the JWST observations represent a major milestone in Neptune research and a long-awaited breakthrough, especially considering the lack of funding for a dedicated Neptune probe mission. At present, the new data from JWST offers a wealth of information, unveiling previously unknown details about the planet's atmosphere, rings, and weather systems. About Neptune, the most mysterious planet in the solar system, this icy giant, bathed in an ethereal blue glow, orbits the Sun at a mind-boggling distance of 28 billion miles, over 30 times farther than our planet. Since Pluto's reclassification in 26, Neptune also holds the title of the farthest measured planet. The 8th planet in our solar system, Neptune also boasts an impressive size. It's the 4th largest planet and the 3rd most massive, packing about 17 times Earth's mass. Interestingly, it's even slightly heavier than its icy twin, Uranus. Speaking of ice, Neptune's primarily made up of gases, liquids, and, you guessed it, ice. This composition earns it the official title of an ice giant. It takes a slow 164.5 earthly years to orbit the Sun. While Galileo Galilei spotted a curious blue blur in the 17th century, he mistook it for a star. Fast forward to 1846, and British mathematician John Couch Adams used calculations to predict the existence of another planet beyond Uranus. French astronomer Urbain Le Verrier independently reached the same conclusion around the same time. It wasn't until German astronomer Johann Gottfried Galle finally spotted the elusive Neptune in the night sky on September 23, 1846, confirming their predictions. Neptune's most striking feature is its vibrant blue color. Of course, this mesmerizing hue is caused by the methane gas that makes up a large portion of its atmosphere. The way methane molecules vibrate absorbs red light, leaving the blue wavelength to dominate the reflected light we see. This celestial blue beauty even inspired its namesake, the Roman god of the sea. Despite its captivating appearance, Neptune remains one of the least explored planets in our solar system. Over the past few decades, scientists have observed dramatic changes in its atmosphere, raising concerns. With limited data, researchers are left scrambling to understand these mysterious shifts. The Great Dark Spot. Neptune holds a few fascinating mysteries, and its weather is definitely one of them. Back in 1989, Voyager 2 flew by the planet and spotted a giant swirling storm, the Great Dark Spot, in Neptune's south, eerily similar to Jupiter's Great Red Spot. But there's a strange thing about this spot. Just a few years later, in 1994, a team of scientists using the Hubble Space Telescope peered at Neptune again, and the Great Dark Spot was gone. In its place, a brand new dark spot appeared in the north. This dark spot must have formed between Voyager's flyby and the Hubble photos. Since then, Hubble has discovered several more black spots. They develop at mid-latitudes in both hemispheres and tend to move in the direction of the equator. But they face certain death if they do that. This disappearance revealed a key difference between Neptune and Jupiter's storms. Unlike Jupiter's Great Red Spot, which has raged for centuries, Neptune's storms are short-lived. They might not last, but they sure do pack a punch. Neptune reigns supreme when it comes to wind speeds. These ferocious storms can whip around at a mind-blowing 1,350 miles per hour. To put that in perspective, the most powerful hurricanes on Earth manage a measly 186 miles per hour. So yeah, getting caught in a Neptune storm wouldn't be ideal. Unexplainable processes on Neptune's surface. Neptune keeps scientists on their toes, especially when it comes to its weather. In 2018, researchers spotted a monstrous storm raging in the planet's north. The giant swirling storm on Neptune was bigger than the entire continental U.S. They tracked it for years, expecting it to follow the usual path south towards the equator, where Neptune's storms tend to vanish. This happens because of a special weather phenomenon. Our planet's rotation creates the Coriolis effect. This fancy term basically means winds moving at different speeds depending on where they are on the planet. Think of a merry-go-round. Things at the edge move faster than things closer to the center. The Coriolis effect acts like an invisible hand, steering winds and shaping storms on Neptune. Storms born near the poles get nudged by the Coriolis effect as they travel south. As they get closer to the equator, this influence weakens, causing the storms to break apart and disappear. But this monster storm in 2018 defied expectations. It defied the Coriolis effect and kept chugging south. That's what makes it so mysterious. But 2020 brought a surprise. Hubble captured the storm doing a U-turn, heading back north. This unprecedented behavior left researchers baffled. Scientists have tracked similar dark spots for nearly 30 years, but this was something new. Was it a rare anomaly or something more? Adding to the mystery, Hubble has observed other dark spots disappearing and reappearing over the years. The largest storm Hubble has ever observed on Neptune was 4,600 miles in diameter. Researchers have been observing the behavior of the storm since 1993, and they noticed that the storm seemed to disappear several times, perhaps actually dissipating, only to reappear not far from where it disappeared. One theory suggests these storms might hide in Neptune's deeper atmosphere before resurfacing. Perhaps the storms disappear only superficially but continue to rage in the deeper layers of Neptune. From time to time, the events could then become visible again on the surface. Unfortunately, we lack data on what's happening down there. The storm continues to surprise. But it doesn't stop there. This storm's about to get even weirder. Just as it defied expectations and reversed course, it appears to have given birth to a smaller companion storm, like a miniature version of itself. This isn't entirely unexpected. Some computer models predict that as giant storms on Neptune weaken near the equator, they might shed smaller whirlwinds. We couldn't directly observe this happening due to limited data, but it's a strong possibility. Maybe shedding this mini-storm helped change direction. Some scientists theorize another oddity is that, unlike most dark storms, this one lacks the usual bright white fringe. These are methane ice clouds, super reflective and appearing white in images. Normally, winds carry methane gas up the storm's high-pressure center. Think of a giant mound of air where it cools and crystallizes into ice clouds. Here on Earth, mountains create similar orographic clouds when moist air rises, cools, and condenses. We saw these white clouds on Neptune in 2019, but they vanished in 2020. Could this be linked to the storm's strange behavior? Maybe, maybe not. Studying Neptune is tough. It's incredibly far away, appears tiny in our telescopes, and its atmosphere changes rapidly. It's high time we explore Neptune. The answer might lie in a future mission to Neptune, similar to Cassini's plunge into Saturn. A probe could dive into Neptune's atmosphere, collecting crucial data. This is still a dream, but Neptune's turn for a dedicated probe mission seems likely. This mission might even have an exciting bonus: the hunt for Planet X. Since Pluto's reclassification, Neptune is the solar system's last major planet. However, wobbly orbits of some objects hint at a hidden giant, Planet X, lurking far beyond Neptune. Planet X, or Planet 9, could have a highly elliptical orbit, taking thousands of years to circle the Sun and remaining invisible under current observation conditions. It might only become a blip on our telescopes every few hundred years. Will a future Neptune mission unveil the secrets of its stormy atmosphere and nab the elusive Planet X? Only time and powerful telescopes will tell. Neptune's largest moon, Triton. James Webb's stunning image of Neptune might have left you wondering about that brilliant blue-green light in the background. Fear not, it's not an alien beacon. That eye-catching sparkle is actually Triton, Neptune's largest moon and the brightest of the moons captured in the image. Roughly the size of our own moon, Triton stands out with its greenish hue. This unique color is a result of the image's special filters, but it also reflects how Triton bathes in the faint sunlight reaching its distant orbit. But unlike most moons, Triton has a smooth, icy surface with barely any craters. Here's where things get interesting. Scientists believe Triton might not always have been Neptune's companion. Its oddly elliptical orbit suggests it could have been a wandering object from the Kuiper belt, eventually stolen by Neptune's gravity. This theory gets even more interesting because Triton travels around Neptune in the opposite direction of the planet's rotation. A big clue that something dramatic happened in the past. But Triton holds even more intrigue. Just like Jupiter's Europa and Saturn's Enceladus, Triton shows signs of ice volcanism, hinting at a possible ocean beneath its icy crust. This possibility makes Neptune and its moons a prime target for future exploration. Triton is a world with a potential ocean and a mysterious past. Its orbit and structure are one of a kind. Until then, we eagerly await the next surprise James Webb has in store for us. JWST, Neptune's rings, and its various moons. Thankfully, space exploration isn't standing still. The incredible images taken by the James Webb Space Telescope, JWST, are helping us piece together the story of Neptune and its 14 incredible moons. Most of these moons are on the smaller side, under 200 kilometers wide, and a bit on the irregular shape side. Think more lumpy potatoes than perfect spheres. One exception is Proteus, which clocks in at a respectable 400 kilometers across. Now, some of these moons are hanging out right in Neptune's rings. These are called the Shepherd moons, named after astronomer Alan Shepard. Scientists think the gravity of Despina and Galatea, two of these moons, might actually be helping to clump the ring particles together into those distinct bands we see. Pretty cool, right? But Triton is a real heavyweight in the world of moons. This isn't your average moon. It defies expectations by orbiting Neptune in a backward motion, meaning it travels in the opposite direction of the planet's rotation. Their leading theory is that Triton wasn't always Neptune's companion. As mentioned earlier, they believe it might have originated in the distant Kuiper belt, a vast region beyond Neptune filled with icy objects. Millions or even billions of years ago, Neptune's powerful gravity might have snagged this sizable object, turning it into its largest moon. However, the exact details of this cosmic capture remain shrouded in mystery. Scientists are eager to learn more about the forces that could have orchestrated such a dramatic event. Clocking in at a whopping 2,700 kilometers wide, it just barely edges out our own moon in size. In fact, Triton is even larger than Pluto, the former ninth planet, which comes in at a mere 2,376 kilometers. But what really makes Triton stand out is its captivating teal color. This vibrant hue isn't just a quirk of the JWST's imaging. Triton really does have a distinct greenish tint, likely due to its surface composition. But it's not just Triton that's caught scientists' attention. Neptune's rings, though faint compared to Saturn's dazzling display, are still fascinating. Like other ring systems in the solar system, they're made up of countless icy particles, ranging in size from tiny grains to boulders. But what sets Neptune's rings apart is their remarkable variety. They aren't just simple, uniform bands like Saturn's. Instead, Neptune's rings are more complex, featuring arcs, clumps, and even braids. This complexity hints at the presence of shepherd moons, small satellites that help shape and maintain the rings through their gravitational influence. It's a delicate dance of gravity and motion, one that scientists are still working to understand.